All right, so today we're going to be talking about graphical user interface again. And this is the second in a two-part lecture where we're going to look at user interfaces in Java. All right. Now, the main things that we're going to be covering, we're going to be commenting on layout managers again, borders, integrating your graphical user interface with an application, and then I'm going to point out a few other useful GUI components that are available in Java. All right, so we covered a little bit on layout managers the last time, and sufficing to say that we also agreed that a layout manager is an object that determines the way that components are arranged in a container. We looked at many different components that can be put in a container last time. Now, there are some predefined layout managers in Java, and it probably would be foolhardy to try and build these from scratch again. The best thing to do is to take what is there, and if you don't like it, you can modify it in some way. All right, so most times you're building an application with a graphical user interface, you build on something that already exists and see how that might be improved to give you what you desire. So the 5 that we're going to talk a little bit about from the AWT library are flow, border, card, grid, and grid bag layout. And then we're going to talk a little bit about the box and the overlay layout, which are part of the swing library. Right? So importantly, as we mentioned the last time, every container has a default layout manager, but we can explicitly set the layout manager to something different. Each layout manager has its own particular rules of governing how the components are going to be arranged. Some pay more attention to the size or alignment, while others, it doesn't matter. So generally, though, a layout manager attempts to adjust the layout as components are added and as the container are resized, so that the program doesn't look out of place, or the adjustments to the size of the window in particular will reflect what is expected of the program. So we can use set layout method to change its layout manager. So for example, if we have a panel, J panel, right? If we have a J panel called panel, we can say panel.set layout, new border layout, and that would actually set up a border layout on the panel. All right. Now, we're going to go through an example which uses a tabbed pane, which is a container that permits one of several panes to be selected. All right. Now, we're going to apply a different layout to each and show you exactly what those look like in code and what running the code will present. So we create a new frame here, which you would have learned from the last time. And we create a new tab pane, and we have intro panel, flow panel, border panel, grid panel, and box panel. We add those to the content pane of the frame, and so now we're going to look at each. All right. So we set up some labels on the intro panel, right, which basically is going to display some text, right, and that's what the result of that looks like. So we end up with having an intro panel, a flow, a border, a grid, and a box. Okay. Now, as we said the last time, the flow layout puts as many components as possible in a row, and then it moves to the next row. So it just continues right across until it reaches the edge, and then it continues the next line. All right. Rows are automatically created to accommodate all of the components, and components are displayed in the order they are added to the container. So if you add 1, then 2, then 3, they will appear in that order. And if there is no space after you add 1 and 2 in the current row, then 3 will automatically flow to the second row. All right. The horizontal and vertical gaps between the components can be explicitly set by using a particular property. So here's an example of the flow layout. We're going to be adding some buttons to the flow layout, right? And when we add the buttons, we notice that if there's space, each button is just gonna appear to the right of each other. All right. Now, if we were to resize, for example, if we were to make the width of the panel or the frames less, then button 5 might go to the next line automatically, or button 4, depending on how small you make it. Okay. So that's how the flow layout actually works. It's the most basic of layouts, and it's the default layout manager if you don't specify a layout manager when you're setting up your panel, your container, then that is going to be set as a default. It doesn't really allow much control over the component in the container, and they will move around as you resize, and there's nothing you can do about it. Alternatively, a border layout defines 5 areas in which components can be added. And you saw an example of this last time. You have the north, center, south, west, and east, right? And primarily here, if one of the areas or segments is not used, then it doesn't consume any space, right? But you can add different things to the different areas by using the region specification. So you could put anything in each segment. Each of the 4 outer areas, they will enlarge or to accommodate the component added to it. And of course, the center area expands to fill space as needed, right? Now here's how we would create that in Java. We set the border layout, and here we can add the same 5 buttons, right, that we had on the previous layout, and we add button 1 to the center, button 2 to the north, button 3 to the south, button 4 to the east, and button 5 to the west, right? And then that is going to be the result. So button 1 is at the top here, right? Then button 5, button 1, button 2 is at the top. Button 5, button 1, button 4, and button 3, right? So that corresponds to what we just discussed. Next layout is the grid, which presents a container's components in a rectangular grid of rows, right? One component is placed in each cell of the grid, and all cells have the same size. Once as components are added, the container then fill up the grid row by row from left to right, top to bottom, and the size of each cell is determined by the overall size of the container. So you'll get fixed size cells. So here's an example of the grid panel with the buttons added just the same. And you will note here that in the resulting picture, button 1 goes first, 2, 3, 4, and 5. And if we added another button, it would have gone here. Okay, notice they're all equal sizes. And the fill up is from left to right, each time, right? That's just how it works. A box layout organizes components horizontally in one row or vertically in one column, and components are placed top to bottom or left to right in the order in which they are added. And by combining multiple containers using box layout, many different configurations can be created depending on what you want to see displayed. Some people prefer to use the more complicated grid bag layout, which we'll talk about a little bit later. But the box layout is particularly useful in cases where you want to also ensure that there are fixed areas which will have certain things. So if you want, for example, to set an area where your buttons must be all the time, right? You want a specific area where all your menu items are going to be displayed, and you can set that as a rigid area. Or you want to be able to specify an area where space is to go when you resize or you maximize or so on. You can set that as a glue. In particular, by using the create horizontal glue or the vertical glue, And then the create rigid area method also is used to create a fixed size area which doesn't necessarily change. And so notice here we add button 1, then we create a rigid area, which is a fixed area, then we add button 2, then we create a vertical glue, then we add button 3, button 4, then we create another rigid area, and then we add button 5. Now that is what the result of that looks like. So button 1, then we have a fixed area that must be there. Then button 2, then we create a space, right? A glue area that any additional space should go. Then button 3, button 4, and then button 5. So because we set rigid areas, that area is going to be fixed no matter what happens. It's not going to be modifiable as the size of the frame changes. Now, in order to make our application look good, we can add borders, right? And borders can be used effectively to group components to make sure that people, for example, can see the different parts of your application and how they come together. So if, for example, you're displaying a form, you might want to border the segments that relate to each other. If, for example, you have like, say, click one of the following to indicate choice, you might want a border around that to show all the choices. I mean, there are many reasons why you want to use borders. And if you use them effectively, they can lead to more elegant application interfaces. Now, we can benefit from the border factory class, which has several static methods for creating border objects that can be applied to a component using the set border method. Now, of course, there are many types. We have an empty, we have a line, we have etched border, we have the bevel, title border, and matte border. And I guess it won't look, you won't get it until you see what they all look like. So here are some examples that we create. A simple line border. Here we create a line border around a particular component here. Here we create an etched border. Here we create a border that has a title, right? So this is something that you might have seen in applications a lot, where a segment of the screen is bordered and a title is there that suggests what that segment is about. And of course, you can put the title to the left, to the right, or at some point in between. Then you can also compound borders. So in this case, we have a raised bevel and a line border being compounded here, and here we have a matte border. Yes? Now, it's pretty straightforward to create these border. For example, you set the layout, then you go to the border factory, and you can create the border of the particular name, and the API documentation defines all of these. So in this case, we have border factory.create empty border, right? Then we have create line border, then we have create etched border, create raised bevel border, and so on and so on, right? Now, that's just a follow-up on some of the things that we would have looked at in less detail the last time. So I just gave you a little bit more detail on those. We're going to talk a little bit now about integrating your graphical user interface with an application. So for example, if you think about, for example, your project, one of the things we would have liked you to get from this is that you can spend your time and write all the logic for your application ahead of time, right? What is to be done. And then you can specify thereafter your graphical user interface, which then allows somebody to do what is to be done. Yes? Now, in such cases, you realize that the graphical user interface will only be connecting the user to what already exists as features in your application. in a particular sequence, yes? Now, in that way, we separate the concerns. We separate the interaction from the actual application logic, right? And we're going to look on that. So recall an object-oriented program is a set of objects that work together to solve a problem. And these objects communicate by sending messages to each other, all right? The objects are usually arranged so that they communicate with each other in some well-understood structure, and the structure is referred to as an architecture. So the simplest architecture is one in which user interface objects communicate directly with an application object, right? And the application object knows how to process the data that the application manages, all right? So the application object can either store data itself, or it can in turn communicate with another object that it manages, or it might communicate with a database, you know, or so. Now, one of the simplest application architecture is called the layered architecture, which you have different components talking to each other from top to bottom or bottom to top, yes? And here's an example of what we would consider to be a layered architecture. So we might have some class called database manager that knows how to add a new record, get a new record, delete a record, or update a record that might be stored in some database or some file, right? Then there might be an event manager which allows for a database, right, object to be accepted, and then we can carry forward some action on this object which is going to be related to this. And then at the top we have some graphical user interface which allows, for example, the user to do something, and that something can be considered to be an event, all right? So in the grand scheme of things, we could have a class, a driver class called event main that basically create an instance of the database manager, create an instance of the app, and then passes that app to an event GUI, and the event GUI allows all the activities that are associated with the app to be run through that interface. Now, this design illustrates separation of concerns. That is, each object has a single set of responsibilities, right? So, for example, the GUI does not attempt to do things that the event manager knows how to do, right? Important point, remember we talked about solid principles. The S in solid is for separation of concerns, right? So then we could almost think, we could eliminate database manager and call it something, we could almost change how records are added, deleted, updated, right? And event manager and event GUI doesn't have to know what happens down here. Yes? We could, for example, when we deploy our application, we could deploy the associated data source to be a file. Later on, we could deploy it to be a relational database. All along, event manager and event GUI knows nothing about what is happening down here. They just know that, event manager just know that, okay, I need to talk to database manager to add new record, get new record, delete, update, and it works. So event manager is not concerned about the details of how data is manipulated. Event GUI is not concerned about how events get created and done, right? It's just dealing with taking an event and applying whatever is necessary, right, based on what event manager provides. Yes? Now, as the GUI is used, the methods of the application object are invoked in response to the user's command. So, for example, an action listener for a button that adds data from the form would basically trigger some action, right? And then that action could actually be invoked by going to the app and invoking a create event, which is then going to know, determine what is to be done with that event, right? Based on what we have implemented in our event manager here. Yes? So event GUI just know how to create an event and pass it. Event manager knows to do with what kind of event it receives, what to do in the case it gets that event. And one of the things that is associated with that is telling the database manager, say, hey, here's an event, do that for me, and give me back any result that I might desire. Yes? So I just want to make sure that you get a sense of how, for example, you could build your database manager and your event manager, right? And then your event interface, right, could be a graphical user interface, it could be a text-based interface or whatever it is, or you could attach multiple different interfaces, right, to the same layers that are below here to get activities done or to provide for different users. We talked about text before. We didn't actually touch on images, and so I wanted to talk a little bit about images. Now, incidentally, JLabel object can be used to display both text and images. Last week we talked mostly about text in relation to JLabel, right? So a label can be composed of text and an image or both at the same time, right? So let's talk a little bit about how that works. Now, the image icon class is used to represent an image that is stored in a label, and the position of the text relative to the image can be set, so you can put the text on the left and the image on the right, and you know, all over. And so we can set up that with some alignment, and here's an example. So we create a JFrame here, right? And then we create an object an object of image icon, and we pass into the image icon constructor devil.gif, of course, or devil.gif has to exist in the current folder based on what we pass in here. Otherwise, we have to put the path to devil.gif. Now, incidentally, just to make a note, primarily image icon handles GIF and JPEGs, right? Just to note. So we create some labels here, 1, 2, and 3, and then we now add the text and the image icon object, right? And we tell it where we want it to be positioned. Yes? And here, same thing here. We add devil right, the icon, and then we have center. Here we have left. Here we have bottom, right? Now the result of that is that image of the devil and the words associated with it being placed on the right, the left, and below appropriately. And this becomes primarily important, especially when you're dealing with, when you're building applications that you need persistent stuff, you know, like a logo, you know, it can be useful. Or, I mean, there are many other reasons why you might want to use an image in your application. Another component which we didn't talk about is a checkbox, which is a button that can be toggled on or off, right? Which is different from a radio button, right? So a checkbox can be on or off. Now, it is represented by a JCheckbox, that's the class, and it generates an action event, okay? Now, a checkbox generates an item event whenever it changes state. So the type of action event that it generates is an item event. Sorry, the checkbox generates an item event and not an action event. Sorry, right? And therefore, as a result, we now have to have an item listener for it. So here's how we'll implement that. We're going to examine a program that uses some checkboxes, and we're going to set up font and so on that will change. So first thing we do is to set up a JFrame, and all of this you'd have seen before. We set up a panel and we add the panel to that frame, right? And this is what it's going to look like. Okay, now essentially what you're supposed to see is that if you check the bold box, the text is supposed to become bold. If you check the italics box, it's supposed to be bold and italics, and if none of them, then you will not you will see the regular text, right? And so here we create some labels and then checkboxes bold and italic, right? And our panel, we have our text that is going to be our label. We set the font of the label, and then we create a checkbox bold. We set the background. We set up the checkbox italic and set the background, and then we now we add the listener to both bold and italic. So we create a new listener, item listener, and then we add those to bold and italic. Now, once we have done that, we add all of those to our panel and set the background to the panel. So now we're gonna focus on the style listener class, which is what is listening on bold and italic, yes? So the style listener class now implements the item listener, not the action listener, the item listener, okay? That's the major difference. Now, that interface has one class called item state changed that expects an item event, okay? So item state change that takes in an item event object. Now, that item event object that it takes in has a method called isSelected. Yes, isSelected. So here, once the button is pressed, it changes the style of the font to plain. And then it says if bold is selected, then we set the style to bold. If italic is selected, then we add to that style the italics option. And then now we update the text by setting it, right, with those options, yes? Now, that is our example of using checkboxes, all right? The next example is using radio buttons. Now, radio buttons are particularly useful when there are a number of options that the user must be given, but they cannot select more than one of the groupings of options. Now, in order to ensure that that is so, we have to make sure we put the radio buttons into what is called a button group, okay? So a group of radio buttons present a set of mutually exclusive options. To define a group of radio buttons that will work together, each radio button is added to button group. And the radio button itself generates an action event, not an item event this time, an action event. So we're gonna look at an example. So we create a frame, we add a panel to that frame, and what we're hoping to do is to replicate what is here, right? So they can either choose that this is comedy, philosophy, or carpentry, okay? Now, here's our panel where we're gonna be setting up the buttons. Notice we have quote options which are set. We create radio buttons, comedy, philosophy, and carpentry, right? And we set up the font, right? Now, we now set the background of each of the radio buttons, right? And then we instantiate those radio buttons with some, and set some text associated with them. And that is why you will see the text here, comedy, philosophy, carpentry, right? Now, once we have created the radio buttons, then we add them to a button group called group, right? By instantiating group, and then we say group.add, and we add the names as we have created them up here, right? And then we add a listener, and notice this, we add a listener to all of the radio buttons independently. Notice we did not add the listener to the button group. We add it to each of the buttons independently. So it's the same quote listener, right, which we're gonna implement now as a inner class, right, that we now add each of these buttons. We add the action listener to each of these. And then, of course, we add them to the panel in order for them to be listened. Now, our code listener implements action listener, which is different from what we just did a while ago. And of course, this takes an action event because action listener has only one method called action perform that takes in an action event. So we implement that. So the first thing we do, because it's a number of radio buttons, we take that event and ask for the source. Yes? Now we take that and put it into an object called source. And then we check if the object is equal to comedy. Yes? Then what do? We set the text to comedy code. If the option is equal to philosophy, then we set the text to philosophy code. And if the option is equal to anything else, then we set it to carpentry code. So essentially, when I click on comedy, you will see this code. When I click on philosophy, you will see a different code. When I click on carpentry, you will see a different code. So in this case, comedy is take my wife, please, and carpentry is measure twice and cut once. Yes? Any questions?
No. No, sir.